All right, for 16 and 17, it says use the equation x squared minus y is greater than 0. And it asks me, would I use solid or dotted when sketching this graph? So remember, if it's greater than or less than, you use a dotted. And if it's greater than equal to or less than equal to, you use a solid. So again, remember, I could change this up to have an equal to with it or not, or be less than or less than equal to. So we want to be sure we know every way that it could be asked. All right, then they asked me, would I shade above or below? Now, you cannot just look at this sign and go, oh, that's greater than, I'm going to shade above. Remember that we need to use a test point. So here's my inequality over here. So I'm going to move this y over to the other side just to make it a little easier to see. That this is, remember when we're graphing an inequality, we start off graphing it just like an equality. So y equals x squared is our parabola. And you also could put that in your calculator to graph it. And then I'm going to use the dotted line, as we said, because it was greater than, and then I'm going to pick a test point of 0, 2. So if I put 0 in for x and 2 in for y, I get 0 is greater than 2. That's not true. So that means that point is not a solution. So that means that my solutions would be on the other side. If I had chosen a point like 0, negative 2, if I put that one in, I get 0 is greater than negative 2, which is a true statement. So that would again tell me to shade on that side. So even though this was greater than, I ended up shading below. So I need to use a test point to determine where to shade. Okay, then for 18, it says, is 1, negative 3 a solution to the following system of inequalities? And again, for it to be true, it has to make both inequalities true. So I'm going to take 1, negative 3 and plug it in. So I'm going to put 1 in for x and negative 3 in for y. And when I do, I get 1 plus 9, which is 10. So 10 is greater than or equal to negative 6. But don't forget, you have to check the other one as well. So x squared plus y squared is less than 9. If I put in 1 for x and negative 3 for y, I get 10 is less than 9. And that is not true. So that is not a solution to the system of inequalities because, again, it has to make both of them true, not just one of them. All right, here's an augmented matrix, again, similar to what we were looking at in our system of 3 equations with 3 unknowns. So the first thing that I'm going to do is I'm going to rewrite this system that they've given me to be sure to include x, y, and z, and to make sure that those values are in alphabetical order so that they're in standard form. So I'm going to do 1x plus 0y plus 2z is equal to 3, as you see here. And then no x, so 0x plus 5y minus 1z is equal to 1. And then here the x should come first, so negative 1x plus no y plus 2z is equal to 5. So once I rewrite that system, then it's easier to pull out the augmented matrix, which would be 1, 0, 2, 3, 0, 5, negative 1, 1, and then negative 1, 0, 2, 5. So that would be my augmented matrix. All right, then for 20 through 27, we're going to use the same set of matrices so that you can just put them in your calculator one time and then do multiple things with them. All right, so first off for number 20, it says, what's the order of matrix C? So remember that its order is its rows by its columns. Now remember that rows go across and columns go up and down. So think about columns in front of buildings, they go up and down. If you're at a concert, you go across the row to your seat, right? So if I'm looking at matrix C, this one has 1, 2 rows, and it has 1 column. So that would be a 2 by 1. This one has 2 rows and 2 columns. All right, then it says in matrix A, what's element A sub 2, 1? Well, the first number is the row it's in, and the second number is the column that it's in. So I'm going to look at matrix A, and I'm going to go to row number 2, column number 1, and that would be negative 2. All right, then they asked me to find A plus B. Now, you could put this in your calculator. It's actually really fast and easy to do without your calculator because all I have is matrix A plus matrix B. I'm just going to say 2 plus negative 1 is 1. Negative 3 plus 4 is 1. Negative 2 plus negative 3 is negative 5, and 1 plus 2 is 3. But I'll show you how to do that in your calculator in just a second as well. All right, so for A plus C, they remember that you can only add matrices if they have the exact same order. So you can see right here, matrix A is a 2 by 2 and matrix C is a 2 by 1. So you can't add those two matrices because they don't have the exact same order. So we just say that's undefined. Now to multiply two matrices, they don't have to have the exact same order. It's just that their inside values and their order have to be the same. So for instance, matrix B is a 2 by 2 and matrix A is a 2 by 2. Since the inside numbers are the same, then I will be able to multiply these. The outside numbers tell me the order of my answer. The outside numbers tell me that my answer is going to be a 2 by 2. All right. So again, you can see right here with A times C, their orders are not the same, but you can still multiply them because the inside numbers are the same. And that also the outside numbers tell me the order of the answer. So that would help me narrow down my multiple choice. All right, so let's go to the calculator and let's put these matrices in and do these computations. All right, so let's put our matrices in our calculator. So we're going to go to second matrix, and then we're going to go over to edit. And so this time matrix A is a 2 by 2. So when I type up here 2 by 2, it just automatically switches for me. And then I can just type right over top of those numbers that are already in there. Let me go back. All right, there we go. So matrix A was 2, -3, -2, and then +1. And we're just hitting enter to move to the next one. Okay, now I'm going to have to quit out of that. And then I'm going to go back to matrix. And I'm going to go over to edit. And now I'm going to go down to matrix B. And I'm going to tell it it's a 2 by 2. And then I'm going to put in -1, 4, -3, and 2. All right, then I'm going to quit out of that, and I'm going to go back to matrix, go back to edit, go down to matrix C, tell it that it's a 2 by 1, and put in 5 and -2. And we actually don't need matrix D, so I'm not going to mess with that one. All right, so let's go back to number 22. And we want to add matrix A plus B. So I'm going to go back to the matrix menu, but stay on names. And I'm going to pick A plus, go back to the matrix menu and pick B. And then there is the same solution we got by adding. Now, we added that by hand much faster than we did typing all that into the calculator. All right, then we've already seen that you can't add A plus C, but just to see what that would look like on your calculator, if you tried that. So if I tried to do A plus C, not only does my calculator tell me that doesn't work, it tells me why it doesn't work. So you can see it says the error message is that your dimensions don't match, right? So then the next one that we had was B times A. So matrix B times B, times matrix A. All right, and there's the answer that was answer choice B there. All right, and then we're going to do A times C. So here's a little shortcut for you. If I scroll back up here to where I already have A and C and hit enter, my calculator retypes that, and then I can just come right here and change that addition to multiplication. And there's my solution for 25. All right, then for 26, it says, what is the inverse of matrix A? So to find the inverse, again, I'm just going to go get matrix A, and then again, when I touch something, it lights up in red. You can see here's your inverse button right here. That's what's putting that -1 on there. And so there's my inverse matrix. Now, if you don't like the decimals, remember you can go to math and just tell it to switch to fraction, and there's the fraction version of it. And then inverse of matrix C, you cannot find the inverse of a non-square matrix. Remember, a square matrix is like a 2 by 2, a 3 by 3, a 4 by 4. So because matrix C is not square, then you're not going to be able to find its inverse. And if something doesn't have an inverse, it's called singular. So if I go back to matrix and I choose matrix C and I ask my calculator to find the inverse, it's going to give me an error message. On some calculators, it'll say error singular, or it might say error invalid dimension. So both of those mean the same thing, just that it's not a square matrix, so that you cannot find its inverse. All right. Now we move into our trigonometry from chapter 7. And so for the first one, it says convert 7 pi over 9 to degrees. So the easy way to do that is to replace pi with what it's equal to, which is 180. So we can do 7 times 180 divided by 9, and that will give us our 140 degrees. All right, if I want to go the opposite way and I want to take that 140 and I want to convert it back to that 7 pi over 9 radians, I need a conversion formula. Now, you don't have to memorize the conversion formula because we know that 180 degrees is equal to pi radians. So divide both sides of that by 180 and you'll have 1 degree is equal to pi over 180 radians. That is your conversion formula. Now over here I have 1 degree, but I don't need 1, I need 140 of them. So I'm going to multiply both sides by 140, and that's going to give me 140 degrees is equal to 140 pi over 180. So if I reduce 140 over 180, that would simplify down to 7 over 9. So there's that same 7 pi over 9. And so if they ask you to give a decimal version of that, then in our calculator, we can just do 7, hit your pi button. I use 3.14 here just to abbreviate. And then divided by 9 gives us the 2 and 44 100ths. All right, so for 30, they asked me to find the exact value of sine 30. So I'm going to be using the unit circle for this. So if we look at our unit circle at 30 degrees, here's our ordered pair right here, square root of 3 over 2, 1/2. All right, so from the unit circle, that was that value we just saw. So remember that sine is your y value, cosine is your x value, so we would choose the y value of 1/2. All right, so cosine negative 3 pi over 4. Negative 3 pi over 4 is not on my circle. I don't like that name, so when I don't like it, I can change it with a coterminal. So I'm going to add 2 pi to get my coterminal. So I need a common denominator. So 2 pi over 1, if I rewrite that with a denominator of 4, I'm multiplying the top and bottom by 4, I would have 8 pi over 4. So negative 3 pi positive 8 pi is going to give me 5 pi over 4. So negative 3 pi over 4, positive 5 pi over 4, two different names for the same angle. And 5 pi over 4 is on my circle. All right, so let's go back and grab our circle. All right, so at 5 pi over 4, you can see our ordered pair is negative square root of 2 over 2, negative square root of 2 over 2. So if we take that back to our problem, then we can see that the cosine is going to be this negative square root of 2 over 2. All right, next one, we have the secant of 5 pi over 6. So that is a value from my circle. Secant is not on my circle, but I know that secant is just 1 over cosine. All right, so let's go to our circle and let's grab 5 pi over 6. So right here at 5 pi over 6, we have negative square root of 3 over 2, 1/2. All right, so negative square root of 3 over 2, 1/2 is our ordered pair. And secant is 1 over cosine. So if the cosine is negative square root of 3 over 2, then we're going to have 1 divided by that, or we're going to have negative square root of 3 over 2 upside down if you want to think of it that way. So 1 divided by negative square root of 3 over 2. Remember, when you're dividing fractions, we multiply by the reciprocal. So that's going to be 1 times 2 over a negative square root of 3. So that would be 2 over negative square root of 3. And we're not allowed to leave a radical in the denominator. So multiply top and bottom by the square root of 3 to rationalize to get our answer. So Again, remember that if you take cosine and turn it upside down, you get secant. So negative square root of 3 over 2, here it is upside down right here. So that would take us to this, and then all we would need to do is just rationalize.